Okay, at number 46, they're asking for the probability of a couple different scenarios. Now, to do this one, or I'll admit the fastest way to do this one isn't this, but first, just to try to see what's going on, let's write out all the possibilities of the sample space like we did in the other chapters. This one might remind you, because you only have two choices, 50-50, it could be a boy or a girl. It's going to look pretty much the same as the heads and tails scenario. Okay, so let's say if we're writing them all out and we're talking about 4 kids, they could be all girls, or we could go all girls and a boy, or we could go all girls and a boy, but the boy could be second here. So just kind of trying to change them in some kind of order. And then we could go, a boy could be here, and back to all girls. Okay, so notice we have 8 outcomes, and if we think about it, right, there's 2 choices here, 2 choices here, 2 choices here, 2 choices here. So 2 times 2 times 2 times 2. So 2 to the 4th, there's going to be 16 different options. So the rest of our list is going to look just like this, except it's going to be all the ones that start with B now. If you notice, that's kind of nice because you can copy down the same list, just start them all with a B. And then very last, we could have all boys. All right, so there's our 16 different options. So what's the probability that all 4 children are girls? Well, I can see just by looking at it that that's only one option out of 16 different scenarios. And I picture if I was doing it without writing that on the list, I could do the 2 times 2 times 2 to realize that there's 16 different scenarios. So the probability of all girls for all 4 is 1 over 2 to the 4th, or 1 over 16. All right, what's the probability that there's 2 girls and 2 boys? Now, this is one we have to be careful about, because see how there's different ways to arrange 2 boys and 2 girls? So there's one that's got 1 of each, or 2 of each. Here's 2 of each. Here's 2 of each. This one looks like 2 of each. That one's got 3, that one's got 3. Oh, and here's another one that's 2 of each. So it looks like there's 1, 2, 3, 4, 5, 6 out of 16. So there's your answer. Now, if you didn't have the whole list written down, how could you figure that out? Well, picture I have 4 spots, and I'm supposed to be choosing how many different ways can I rearrange 2 things within there, right? 2 girls or 2 boys. So if I wanted another way to figure that out, I could say, okay, well, I have 4 spots, and I'm choosing 2 boys or 2 girls. How many different ways can I arrange that if I have 2 G's and 2 B's? So that's 4 choose 2. And so remember from our formulas, the choose one is 4 factorial over the smaller number, and then 4 minus 2 factorial, which is also 2. So 4 factorial is 4 times 3 times 2 times 1. Both of these on the bottom are 2 times 1. You can be a little lazy about writing times 1 if you want to, because times 1 doesn't do anything. So this cancels, and I have 12 over 2, or 6. And so there's another way to get, oh, how many different ways can I arrange 2 things in 4 spots? There's 6 ways to arrange that. So same as counting them up here, I can see the probability of 2 boys and 2 girls is 6 over 16. And then if I can reduce that, I want to. So 3/8 is that probability. Okay, so the next one wants to know what's the probability that the youngest child is a girl. So let's see how many of them have the youngest one as a girl. So let's say this is first, this is last, right? So we'll say this is the youngest. So there's 1, 2, 3, 4, 5, 6, 7, 8 out of 16. And so 8 out of 16 is a fraction, reduces to 1/2, right? So the probability that the youngest is a girl is 8 out of 16, or 1/2. All right, let's think about how else we could have figured that out. Well, let's think, what's the probability that the youngest child's a girl? That means it doesn't matter what happens in the first 3, right? You're only focusing on the youngest one. So what's the probability that any spot is a girl or a boy? Is 50-50, so that's the same as that 1/2. So same thing, we could go through and count them and see that 8 out of 16 have an oldest child as a boy, but we could also think, well, if all we care about is one position, what's the odds that any one position is a boy? Is 1/2. So same idea, if I count up how many start with B, it'll be 8 out of 16 or 1/2. Or I can just think about, it doesn't matter what happens in the other spots, there's a 50-50 chance that the oldest is a boy.